Hello students of class 9th. Today we will discuss and prove the criteria of congruency of triangles. So as you know that there are SAS congruency of triangle and ASA congruency, AAS congruency, then SSS congruency, then RHS congruency. So one by one we will prove all the congruencies. So first one is SAS congruency, congruence rule. This is exam 1. The statement is two triangles are congruent if two sides and the included angle of one triangle are equal to the two sides and included angle of the other triangle. So let us consider these two triangles, triangle ABC and triangle DEF. Now two sides are equal. So let BC be equal to EF and AB be equal to DE. Now included angle is this angle, angle B, and here the included angle is angle E. So these two angles are equal. So we need not to prove it. It is an exam. What you have studied in Euclid geometry, that two shapes or two lines are equal when they coincide with each other. So this was exam 4 in Euclid's geometry. Similarly, if we will coincide E with B, then automatically C will coincide with F and A will coincide with D. So in other words, if we superimpose DEF, triangle DEF on AB's triangle ABC, then each part will be coincide. This is enough to prove that when sides are equal, then two triangles are congruent. So it is a reality. It's need not to be proved. So this is exam, not the theorem. Now guys, we'll come to the congruence rule part 2, that is ASA, angle side angle. So suppose the statement is that triangles are congruent if two angles, here you are looking two angles and their included side. So BC and E, in this triangle BC is the included side and here EF is the included side, and both are equal. Two included angle of one triangle are equal to the two angles and the included side of another triangle. So it is given that these two triangles are congruent according to the statement. These two triangles are congruent if the two angles and the included sides are equal. So let us prove it. So we'll prove it in three cases, which I have written, but now I am explaining it to you. Case 1, suppose AB is equal to D. Then in this case, side angle side and side angle side, according to SAS, these two triangles will be congruent if AB is equal to D. This was first case. Now in the second case, suppose AB is greater than D, then we will take any point P here such that BP is equal to D. Then triangle PBC will be congruent to triangle DEF, which I have written in the, you will see I have already explained in written also. So but angle C is equal to angle F. It means it is only possible when P coincides with A. So ultimately triangle ABC will be congruent to triangle DEF. Now case 3, suppose DE is greater than AB. Then in the outside of the triangle there is one point. Suppose the point is E, then EBC, EB will be equal to D, and then by SAS congruency again these two triangles will be congruent. When these two triangles will be congruent, then by CPCT angle C will be equal to angle F. But it is only possible where any point E here coincides with A. It means that in any case, if a pair of angles and included sides are equal, then the triangles are congruent. So angle side congruency. Now suppose first I read out the statement. Two triangles are congruent if any two pair of angle and one pair of corresponding sides are equal. So suppose these two angles is a pair of angle and these two angles are the pair of angles. So this angle is this equal to this and this angle is equal to this, and corresponding side, it is BC, will be equal to DF. Then these two triangles are congruent. We have to prove it. Now I have written all the things given to prove and prove, but I will explain in the figure itself. So now in this triangle ABC and DEF, angle A is equal to angle D, angle B is equal to angle E. Therefore ultimately angle C will be equal to angle F, because the sum of these three sides equal to 180 degree and some of these three angles are equal to 180 degree and some of these three angles are equal to 180 degree. But this angle is equal to this angle and this angle is equal to this angle. Angle B is equal to angle E and angle A is equal to D. So ultimately angle C is equal to angle F. Now ultimately angle F is equal to angle C. Then by angle side angle congruency, these two triangles are congruent. So this was congruence rule 3. Now guys, we'll come to a side congruence rule. Now in this congruence rule, if corresponding three sides, all the three sides of one triangle is equal to the all the three sides of another triangle, corresponding sides, then the triangle is congruent. This we have to prove. So the given is AB is equal to D, BC is equal to EF, and AC is equal to DF. So the trick to prove these two triangles as congruent is that if we prove that angle A is equal to angle D, then by side angle side rule, these two triangles will be congruent. So we'll do a construction here. Below the triangle DEF, we will construct another triangle such that D is equal to FG and DF is equal to FG. Now, angle FEG is equal to angle B and angle EFG is equal to angle C. Then in this case, triangle ABC will be congruent to triangle EFG by angle side angle criteria. Similarly, we can prove that now this triangle is congruent to ABC. Now we will prove that triangle DEF is also congruent to EGF. Means these two triangles are congruent. When these two triangles are congruent, then by CPCT, angle D will be equal to angle G. Then by side angle rule, these two triangles will be congruent. Hence, we have proved side congruency. Hello guys, now we'll prove RHS criteria of congruency of right triangles. So let us read the statement. The two right angle triangles are congruent if one side and the hypotenuse of the other are respectively equal to the corresponding side of the hypotenuse of the other. Means we have to prove that two triangles are congruent if either one corresponding side hypotenuse are equal, and one angle should be corresponding angle should be right angle. So let us consider this triangle ABC and DEF such that angle B and is equal to angle E is equal to 90 degree, AC is equal to AD, AC is equal to DF, both are hypotenuse, and base BC is equal to EF. Now we have to prove that these two triangles are congruent. Let us do one construction, that is we will produce DE up to G such that EG is equal to AB, and we'll join FG also. So now these two triangles, triangle ABC will be congruent to triangle GEF because of SAS criteria, because this side is equal to this side, these two sides are equal. Then by construction, AB will be equal to EG, then it is right angle. Therefore by SAS criteria, these two triangles will be congruent. Similarly, we can prove that these two triangles are also congruent because here we can prove that angle G is equal to angle D. Then this angle E and angle D are equal, means and angle A is equal to angle D, angle B is equal to angle E. Then ultimately angle C will be equal to angle F. So this will be an isosceles triangle. Therefore, angle D will be equal to angle G. Now we have proved that angle A is equal to angle G. This implies that angle A is equal to angle D. Now angle A is equal to angle D, we have proved. Angle B is equal to angle E. So ultimately this angle C will be equal to angle F. So by angle side angle, these two triangles are congruent. It means triangle ABC is congruent to triangle DEF.